And so welcome back to another episode of PyTorch Lightning. I was a bit confused about this trainer. So today we're going to be figuring out how we can implement a trainer from scratch with pseudocode. Like it's not going to be the one we are going to be using at the end. We're going to be using the PyTorch Lightning one. But nevertheless, we're going to be doing step by step and figure out how these things work internally. And we will compare the code we are going to be writing with the code that we can find on GitHub, right? So it's open source. We can always go back to the GitHub and check what's written over there. So William, can you explain to me what are we doing today?
The trainer in Lightning is, under the hood, the operations that it does are pretty complicated. So you might run into 5 lines that are very dense, but are distributing gradients or something across many GPUs or whatever, right? So to help people understand how this is exactly kind of the same as you would in your own training loop, I'd love to walk you through kind of a pseudocode example of what happens under the hood and what is a trainer. So in essence, helping people build their own trainers, but like a much simpler, less finely tuned version, right? So the Lightning trainer has been heavily optimized by hundreds of people at this point, and the collective years of work into it. So it's very optimal. But I think it's really cool for people to be able to do their own basic version. So like anything, the first thing we're gonna do is just install Lightning, right? Okay. So this capture is going to make it so that you don't print a bunch of install stuff. Mm-hmm. And then we're gonna import a few things, right? So just standard PyTorch, first line, then Lightning, and then mnist. So everyone's familiar with it. 10 digits, images 28 by 28. So we're gonna bring those in. Now we're gonna pretend this is a data loader, right? So in Lightning and PyTorch, you use data loaders, and data loaders take data and then shuffle it for you, batch it up for you, so you don't have to do that. So we're gonna pretend that's it, but it's really just mnist here, right? So this is nothing crazy. And then we're gonna pretend we have a super complex neural network here. Wow. So my deep super complex network is going to go from 28 by 28 to 10, right?
Okay.
So it's just a linear layer here. So fancy GPU regression. And then we're gonna have an optimizer. In this case, it's just gonna be Atom, right? Okay. So we do need to bring it from PyTorch. So we're gonna do that. Let's do that. So from torch.optim imports Atom. All right, great. Okay, so we have, okay, so I guess I need to pass in a path where that's gonna download. Okay, fine. mnist. You also have to pass download. All right, so it's gonna download, perfect. And we're good to go. All right, next thing is this linear. So we need torch linear as well, right? So from torch import nn. Okay, and then we need params, encoder. Okay, great. Okay, so we have our encoder, our crazy network, and then we have our optimizer here. So these are the 3 kind of main ingredients, right? Data, model, and then optimizer. Mm-hmm. Lightning, you would normally define the optimizer in the model, but in this case, because I want to show you a simplified version, we're just going to pass it into our trainer. So what we want to build is something like this, right? That looks like this. Trainer, okay. And then we can say trainer.fits, and then you're going to pass in this model, right? This encoder. Mm-hmm. And then we're going to pass in this data loader, so data, and then my optimizer, right? Okay. Great. So it's just kind of the kind of experience that we want right now. In real Lightning, you wouldn't do this. You would do this, right? Mm-hmm. Okay. So the first thing we want to do is let's just define this class called trainer, right? And this class trainer is going to do a few things, right? So let's just pretend that we have very simple, kind of not even any features really. We're just gonna leave it like this. In the init, we're gonna do nothing. And this isn't inherent from anything, so I don't have to call super init. So I'm just gonna say, okay, well, maybe let's do one feature called max epochs, right? We just want to make sure this can only train for so many epochs. Call it 10. So we're gonna say, okay, max epochs equals max epochs, right?
Mm-hmm.
Great. So now my trainer can do max epochs.
Sure.
And now we're going to define this fit function, right? So it's here. So remember, we were trying to say, I want the model, I want the data. So
I
trainer.
don't remember because you erased the you erased the cell. Can you create the cell again?
Oh yeah, sorry.
Thank you.
Okay, trainer equals trainer.
And so here we can pass the max epochs, right? In the first one.
Max epochs equals 10.
Okay.
And then fits, you pass in the encoder, the data,
Mm-hmm.
and then the optimizer.
Okay.
Great. So that's what we want. This won't work, right? So I won't run it.
Sure, sure.
So we have trainer here. This guy is here.
Yeah.
Max epochs is this argument here. And then fit is going to be this function, right? So we're going to pass in this model. And let me just jump into Lightning so I can show you that we're exactly doing the same thing right now, right? So in Lightning, you go here, you go to the trainer. There's this trainer file here.
Mm-hmm.
You know, ours is definitely more complex, but you know, same thing. Class,
Okay.
you init some stuff. We do have max epochs here, which is
Okay,
great.
I see. Yeah.
And then we also have fits here, just function, right?
I see. Okay.
We're getting the model, the data, and then this is mostly just options for data for us.
Mm-hmm.
So we're gonna do this here. So I don't need to do anything fancy. I'm just gonna start looping over my data, right? So I'm gonna say for epoch in range self.max epochs.
Mm-hmm.
I mean, this is what we all do when we write our PyTorch code, right? Or any machine learning code, really. So we're gonna also loop over our data, right? So we have this data here in train loader, right? Great. So now we're gonna look at every batch of data, and now we're just gonna do some magic, right? What's that magic is we're going to calculate a loss, right? So first we need x comma y equals batch, right? That's gonna be my this image label, and then I'm going to create a loss, right? And I'm gonna leave this blank for now because it's not important how we calculate the loss, but it's fine. So once we calculate that loss, we need to do backward on that loss, right?
Mm-hmm.
So we call backward, and then we do these, you know, what you call the magic steps, right? So optimizer dot step, and then optimizer dot zero grad, and that's basically it, right? So you could arbitrarily put this up here if you wanted to, right? Do it first. In Lightning, we do it last because it just makes a lot of other stuff simpler.
Mm-hmm.
So this is basically it under the hood, right? Like
I see.
This is just what's happening here. So
and there should be like the loss should be like something with the model, right? So
yeah, exactly. So let's do that, right? So we can do something like this there. It's simpler.
Well,
well, we need cross entropy, sure, but let's just say
exactly. Let's do that way.
Yeah, let's do it here. So we're gonna flatten this thing, right?
Sure. Okay.
It's gonna be the batch size, whatever that is. So size 0, and then we're gonna flatten everything else since it's 28 by 28, and then the model's gonna take that. I'll put it here.
Let's call that's not x hat, but let's call that logit, right?
Logit.
Yeah.
So I'm gonna cheat right now. I'm not actually gonna calculate cross entropy. I'm just gonna sum this, right? That, like that. I'm gonna call that my loss.
Oh my god! All right, it's gonna work.
Yeah. So we do that, and this is a scalar now. For this loss, all you need is a scalar, right? So
sure, we can also import the cross entropy, right? It's okay. We can do that, right? All right.
So we're gonna calculate the logit now. Cross entropy is gonna take in my logits and then my y here.
Yeah.
Right? And then we're good to go. So here's our loss. Okay, so that's pretty much it. So if you notice in Lightning though, when you look through fits, we do this, right? We link up our data, and then we set up this training stuff, which is boilerplate things. And then we decide what we're going to use for the loops. The training loop is going to be this function. The validation loop is going to be this. And then the test loop is going to be that, right? So notice in fits, I don't actually have that loop that we have here. Like we don't have this in fits.
Yeah. Where is it?
It's another function called train.
Oh,
right?
I see. Okay.
So we just pass it there.
I
And
see.
the reason for that is, for readability, reuse of encode, all that stuff, right?
Sure.
So I'm just going to call that function from here.
Okay.
So train, and then I'm going to pass this stuff in.
Sure.
Model train loader. Okay, great. So now we're kind of matching the Lightning template.
Okay.
Okay, so let's look at what happens in train.
Mm.
So I go to train, and then we use the same names everywhere, but really it's the same file. So I don't actually have to go anywhere. I just look for train, and it's here.
Okay.
Right? Okay, so we do a bunch of stuff, boilerplate. Now you notice there's this thing called a hook here, right? So we're calling this function.
Mm.
So let's make our own hook here. So we're gonna do that too.
What's the hook?
Yeah. So imagine that. Let's do an analogy here, right? So imagine that your training is like this. It's like the first thing that executes all the way through to like your program ends, right?
Okay. Yeah.
And program start. Okay. Now in here, you want access to what's happening in here, right? And something that Lightning excels at is giving users full control of everything they do. So if you wanted to call something here, right, then you need like basically a hook, a way to hook into this line, right? So imagine there's like a hook here and another hook here, another hook here. And that lets you basically do something at this part of training, right? So a concrete example is if I wanted to do something before I flatten my batch, maybe I want to create a function here called on batch start, right? And then as a user, when I have my own model, right, I can then do something like this, right? I can say class model, right? And then here I just implement that function. And then like I can just do this, right? Print hello. So it's the same thing if I just done that. It's basically like if I had just done this, right? So
yeah, but that's model. Whoa, sorry, I lost. On the second cell, you just wrote class model, but now we are inside the trainer. How is this model connected?
Yeah. So in Lightning, we let you override these hooks in your model so that you don't have to go directly into the code. Right?
Oh, so inside my model, which was encoder before, right?
Yeah, exactly. So it's just encoder here. So now we're using a better syntax, right? So
I see.
If I wanted to write the same thing, kind of more usable, I guess, I would do something like this, right? So I could do this and then set it up this way.
Self, also self inside the init.
Yeah, and then
this is gonna be encoder, right?
Correct. So it's encoder, and then I have here my def forward, right? And then I have self x, and then I just return self.encoder.
Yeah, sure.
Great. So that's my model now. But now I have this added thing, right?
Inside the model.
Yeah, inside the model. So these are optional, right? So what if like here I wanted to modify that batch, right? So like before I do something with the batch, let's do it here, right? Before you give me that batch, actually here, I could just pass the batch in, right? And now you have access to the batch, and now you can do whatever you want, right? You can say like, let's just say I call it modified batch, right? I can do that, and now I can do something like return 1,2. That's a new batch, right? So it lets me have full control over the model. Now, what's cool about Lightning is that in Lightning, the models, right? So let's call this a module. It's actually a subclass of this thing, right? It's the same thing as the n.module, but it has these added hooks that you can use. So what's cool about it is that it's self-contained, right? So you no longer have to pollute this code with like, print this, right? Or like modify my batch somehow, right? So it makes your research and your when you're writing this code more reusable.
I see.
So that you don't have to do it. And then that way, when I share this model with you, you have every ingredient you need to run this thing. You're no longer hunting through like 200 files to figure out what's what. Okay. So that's a hook, right? So we're gonna just leave that hook there on batch start. Great. Okay, so we can add arbitrary hooks, more of these. So let me talk about another concept in Lightning. It's the training step, right? So here, we have a function called training step, right? Here.
Do I have to write this down?
It's in the docs, right? So all of this.
I mean, is it mandatory? Do I have to use it?
Yeah, you do have to use it.
Oh,
right?
okay.
This is the core. So you don't actually need forward in Lightning, right? You can drop it.
Oh,
We'll
I don't know. Okay.
Yeah. So just training stuff. So let's leave this for a second here.
Uh-huh.
So imagine you did this. Right? I didn't do anything. I just encapsulated what you cared about.
Sure.
This is where you're going to spend most of your time. Like this stuff is automatic. Like you're not really going to do anything here. And this stuff is pretty much automatic, right?
Mm-hmm. Okay.
So Lightning, you just call it the training step. So this is the training step now. That's really it.
Oh, I see. So is this a hook?
Yeah, correct. It's a hook.
Oh, wow. Okay. See, I actually understand something.
So we're gonna leave that as the training step, right?
Yeah,
So,
yeah, I see that. Okay.
So we're just
So
gonna.
there is okay. So I guess now on GitHub there should be some model.training step in the underscore train.
Let's step it here. So we had the for epoch, right? Same thing.
Yeah.
Right there. And then we're going to actually run a training epoch. So for modularity, we like put it in this function, right? But this code here is this part here, right? So we're gonna look through a data loader. So we go through, we find this function. So run training epoch. So you get the model, right? Bunch of data stuff. And then we're back again here, batch index for data loader, right?
Yeah.
So we already had that here.
Yeah.
In line here, it's this guy here. And then we're gonna do the training step. So big comments, training step. So we're gonna run the training batch in here. So now, again, because our code is a little bit more complex, since we have to handle a lot of cases, we just run this function here. So we run the training step, and then do a bunch of other stuff. So let's just look at the training step real quick. You look through here, and then you see, again, more complexity because it is for more complex cases. So here we support automatic truncated backprop through time for NLP applications. And then for like, things like GANs or RL. So we get it. And then here is where actually the training step happens in here, right? So let me show you here. So training step and backward, we do that here. And then you actually will see that we call the model here somewhere. Where is it? There you go, right there. So it's a
okay, finally. So this line, the results equals self dot training underscore step is the same one that we just defined, is it?
Yeah, correct. So we're gonna get this loss here.
Okay. And so on this one, I have to write inside my model definition, my Lightning model. So my Lightning model doesn't need the forward, as you just told me. So we can remove the forward. Is it correct?
Yes, correct.
And then we can replace the. So instead of having model here, logit is no longer model. It's going to be self, I believe, right?
Yeah.
Self encoder X. Okay.
Right. So you can do this. This is the minimal code you need.
I see. Okay, I understand.
So why do we add forward in Lightning? It's really for inference and predictions. So that's pretty much it. That's just what you would need to build the trainer.
So what are these callbacks? So you mentioned a few times, these callbacks, and actually you mentioned hooks. And what are these hooks, callbacks, and then how do we create a hook? So we can generate these hooks by adding methods to my model, you said? Yeah. But can I create, I don't know, like a system where I store my hooks for multiple use cases? Is it possible?
Yeah, that is a callback, right? So, and callback is a concept from like software engineering, like web development, where you would have, for example, in JavaScript, you would have sent a request to a website, and that might take a minute to reply, right? Oh. So you're waiting for it to call back to you.
Oh. Okay, I didn't know. Okay.
Yeah.
So where can I read more about this stuff? Is it on Wikipedia? Callbacks? Definitions? I don't know the definitions.
Callbacks, Wikipedia. Let's see. Yeah, there we go. So computer programming, a callback, also known as a call after. I've never heard call after, but sure. Is any executable code that is passed as an argument to other code.
Okay.
That other code is expected to call back or execute the argument at a given time. Right. Imagine that I had something like this. Like I was like debugging, right? Or like maybe I needed to like log something for my research, right? So I had like, okay, ABC, maybe I want to log like the batch size, right? Or something like that. And then I also wanted to do like the loss, right? Like maybe I'm just like, oh, let's log this loss to see what it's like, right? And I do this.
3 S's, loss.
And then maybe I want to like inspect my gradients here, right?
Okay.
So
Yeah. So let's say, yeah, I would like to do something.
so maybe I want to look at my gradients. So loss.
Let's say I like to create like a debugging version.
What about taking the norm of weights? Like that's a useful thing for people, right? So
Yeah, or the norm. Yeah.
let's do it here. We want to take the norm here, right?
Mm.
So let's just say we have this function called torch.norm, and then we're going to pass in the weights, right? So we have this model, and we're going to use this guy now. So let's just use the encoder. So a single layer, and then model.encoder, right? Because that's the name of it.
Mm-hmm.
And then the weights, and then the grad. And we're going to take the 2 norm. I guess you would need to do that once you have the gradients, right? So here. Great.
Yeah, if you do that after the 0 step, you're gonna get 0.
Yeah, exactly. So let's just take the norm here, right? Okay, so now what happened? Look, this is super messy, right? And like, you don't really want to be doing this stuff. Like,
no, I don't. Exactly.
you want to clean your code, right?
Yes, we want to clean.
So let's create something that's gonna capture all of these in a single place. So that's gonna be a callback. So let's call this our norm callback, right?
And the hook instead, what's the hook?
These methods within a callback, like this is a hook, right?
Okay. So a callback is the class, I guess, and then the class has different hooks where I can get myself hooked.
Exactly. So let me show you in Lightning, right? So you can go to the docs here, and then we have callbacks, right? So this is, an optimal extension. You don't have to use it, and I explain it in depth here.
Okay.
But you can see kind of how it flows in this kind of animation, right? So the code is flowing, and as the code goes, like here, I would call this particular hook, right? Train data loader. That's and then here, I could call train epoch start right there, or train epoch end right here, right? So this animation shows you where all those hooks are, and it shows you, I think at the end it shows you all of them together. Let's see. Yeah, so see all of the hooks. We have over 40 hooks in Lightning.
Wow. Okay. So let's create our callback with a few hooks, not all of them.
Yeah. So check this out. So this callback has these options. There are more options. We just showed a few of them here, right? But these are hooks. All these hooks here. So let's create our own hook.
Okay.
So we're doing this like random thing here now. We're printing, and this location is like if you wanted to call this something, like what is something reasonable? Like, okay, well, the batch is starting, right? So we're gonna make that name up. So call it self.on batch start, right? Well, it's part of the model, right?
Yeah.
So let's do this first, right? So first before we do this, let's pass in our callback here. So imagine we had an argument called callbacks, right? And that's going to take a list of things. And then one of those things is going to be our callback. So what do we call it here? A norm callback, right? We're going to pass this guy in. Well, we're going to initialize it in here, right? So we're going to pass this guy in. So sorry, let me do it this way. It's going to be callbacks, and then I'm going to initialize it here. So callback this guy, and then pass it in.
Yeah.
Done. Okay, so I'm passing it in, and my trainer is going to receive it here.
Yeah.
And then I'm just gonna, this bad practice, don't ever put a list into an init, FYI. So we're gonna use a none there.
Sure.
And then, we'll guard against that none. So is none, then we'll do self.callbacks equals list. Great.
Sure.
Okay, so now we have this list of callbacks. So I wanna call this hook on every single one of those callbacks. So let me write a function called this onBatch start, right? In the trainer, and then this is going to loop through all my callbacks. So for callback in callbacks, and then I'm going to
I see.
call my callback on batch start, right? Done. So I can put a list of them.
But before you said that there were callbacks, there were hooks in my model, no?
Yeah, the model can also have hooks, right? So in the real Lightning, you would do something like model. You would call something like model dot on batch start as well.
I see. Okay.
And then you would also call the hooks for the callbacks.
Okay.
So we're going to add this hook here on batch start. So great. So now whenever the batch starts, the trainer is going to call this function, and that function is going to call the models on batch start, and then all of the callbacks on batch start. So now we have like deterministic behavior that is modular. Great. So my norm callback now is going to be this guy. And you know, I don't need to inherit from anything in this case. Well, in Lightning you would inherit from a callback, right? So that implements that. And then I'm going to implement that method on batch start. Now in the real Lightning, that method gets something else, right? So let's look at what those are. So here I can just look down, I can search on batch start, and I see it here, right? So there it is. You know what it's looking for. So it's looking for, it's going to pass in the trainer, the module, batch index, and a data loader index. So let's pass the same arguments here.
Okay.
And then
self. Yeah. Okay.
Okay. So now we need to modify our hook now because it's changed, right? So we're going to call batch start. Well, here, what do I need? I need the badge. So I need the trainer, right? I'm inside the trainer, so I can pass self. I need the model. So the model is right here, so I can just pass that in. I also need the batch. Well, the batch is right there, so I can patch this in. And then I can pass the batch index. I don't have a batch index, so I'm going to fake it here, right? And then I can just increase it here.
Sure.
Okay, great. So I'm going to pass in the batch index and then a data loader index. Well, we only have a single data loader, so I'm going to make that 0 for now. In Lightning, we support multiple, so that's why that's there. Great.
And batch index too, right? On the
yes, batch index. Oop, here.
But we were doing this for the computation of the norm, right? Not this batch start.
Yeah, correct. So I'm gonna do the same thing for here. So let's just say
I see. Okay, I understand.
Batch and let's call it, right? So
I see.
Actually we have one called on after backward. Backward. Okay. So that's going to happen. And I think the arguments are pretty much the same. So we're going to call that. And then now we're just going to move this code there. This norm, done. And then that's it. So now we've gotten rid of this. We don't actually need this guy, right? Because we're not going to actually use that one. And we don't need this print. So now we've generalized our code. Now we just rename this method here so that it matches, right? So now the trainer is going to call on after backward of the model, and then for every callback, and then we're good. So now you like factor out that code. So now your code is still clean. You're not doing anything crazy to it. Now when I want to run this, now you just have that here, right? You just pass it in. So you would instantiate this callback. You would instantiate this callback here. This callback, this guy.
Sure.
And then the trainer that you created, max epochs, callbacks, and then you call encoder, trainer, and optimizer. So,
okay. So I think it starts making sense. So today we understood what's inside the trainer. This trainer has plenty of hooks, and then a collection of hooks can be stored inside a callback, which is a class. So it was like a high-level overview without actually running the code. So how about next episode we implement a callback for making something concrete? Let's say, I don't know, like computing some gradient ascent in a logit space to figure out, how we can mess the network prediction, right? Does it sound good?
Yeah, it sounds perfect.
Okay, so this was very great. Thank you so much, William. I really understood and learned so much today. All right. Take care. Bye-bye.
See you.